Have you ever wondered what the air on a distant exoplanet might be like? Would it be breathable, or would it be a cocktail of alien gases? Welcome, fellow explorers, to the vast cosmic arena of space where we'll journey beyond the familiar. Out there, in the vast expanse, lie exoplanets, celestial bodies orbiting stars outside our solar system, each with their unique atmospheres. An atmosphere, in essence, is a layer of gases surrounding a planet. It's what makes life as we know it possible here on Earth. But how do scientists, bound by Earth's gravity, study these distant atmospheres? They use a fascinating method called spectroscopy, which allows them to identify the chemical makeup of these atmospheres by examining the light that filters through them. This cosmic venture will introduce you to the strange, the beautiful, and the downright alien. Now, let's dive into the countdown of the top 5 strangest exoplanetary atmospheres discovered so far. At number 5, we have HD 189733b, a planet where it rains glass, sideways. Now, that's a weather forecast you don't hear every day. This exoplanet, located about 63 light-years away from us, has a rather peculiar atmospheric phenomenon. Its atmosphere contains high concentrations of silicate particles. When these particles are exposed to the extreme temperatures of the planet's day side, they melt and condense to form tiny droplets of glass. But that's not all. This planet also boasts incredibly strong winds, some reaching up to 7,000 kilometers per hour. These winds are so powerful, they whisk the glass droplets sideways, creating the unique spectacle of sideways glass rain. It's a world of scorching heat, violent winds, and glass rainstorms. A place so hostile, it's almost poetic in its ferocity. Imagine a world where you'd need an umbrella made of steel. That's HD 189733b for you. At number 4, we have HAT P7b, a planet with an atmosphere that could give its sky a ruby hue. Imagine a world where the sky isn't blue or even the orange-red we see at sunset. On HAT P7b, the sky could shimmer with the deep, rich reds and purples of a ruby gemstone. This exoplanet's unique atmosphere contains high concentrations of Al2O3, also known as corundum. This is the very mineral that forms precious gems like rubies and sapphires here on Earth. Now picture the sun setting on HAT P7b. The corundum particles in the atmosphere would scatter the sunlight, potentially creating a dazzling display of purples, pinks, and deep reds across the sky. It's a spectacle that could rival even the most breathtaking sunsets on Earth. But this is no ordinary sunset. This is a cosmic ballet of light and minerals playing out on a planetary stage millions of miles away from our own world. A gemstone sky on a planet light years away, that's HAT P7b. Coming in at number 3 is Kelt 9b, a planet with an atmosphere so hot it's actually metallic. This gas giant is a scorching example of the incredible diversity in our universe. It orbits its star, Kelt 9, at such a close distance that the star's intense heat causes the planet's atmosphere to reach temperatures exceeding 7,000 degrees Celsius. That's hotter than the surface of some stars. In this blistering heat, metals like iron and titanium vaporize, becoming ionized and forming a metallic atmosphere. This is a phenomenon we don't see in our own solar system. It's a stark reminder of how different and how extreme conditions can be on exoplanets. But what does this mean for life as we know it? Well, the extreme conditions on Kelt 9b make it inhospitable for life, at least as we understand it. It's a harsh environment where even metals vaporize. A world too hot to handle, Kelt 9b is a testament to the extremes of the universe. Our runner-up is WASP-12b, a planet with an atmosphere so hot it's more like a star than a planet. This exoplanet, located a staggering 1,400 light-years away from Earth, is wrapped in a plasmatic atmosphere. This isn't just a fancy term for very hot. We're talking about temperatures so extreme they cause the gas molecules in the atmosphere to ionize, transforming into a state of matter known as plasma. In the case of WASP-12b, this is mainly due to its uncomfortably close proximity to its host star. It's so close, in fact, that it completes an orbit in just over 1 Earth day. This intense, close relationship with its star means the planet is constantly bathed in stellar radiation, creating an atmosphere that is not only plasmatic, but also expanding at an enormous rate. With an atmosphere that could rival a star's, WASP-12b truly blurs the line between planet and star. And finally, at number 1, we have 55 Cancri e, a planet whose atmosphere could be rich in diamonds. This is not a tale from a science fiction novel, but a reality that unfolds in our vast universe. Nestled approximately 40 light-years away in the constellation of Cancer, this gem of a planet, 55 Cancri E, holds an atmosphere that could be teeming with diamonds. This super-Earth exoplanet is drenched in a sea of carbon and hydrogen. Now you might wonder, why does that matter? Well, when these two elements are subjected to extreme heat and pressure, something miraculous happens. They combine and crystallize to form diamonds. Yes, you heard it right, diamonds. Unimaginable quantities of these precious stones could be floating in the atmosphere of 55 Cancri E. But how did we stumble upon this astonishing discovery? It's all down to the science of spectroscopy. When light from the planet's star passes through the planet's atmosphere, it leaves specific signatures, which can tell us about the atmosphere's composition. And in the case of 55 Cancri E, those signatures hinted at an abundance of carbon and hydrogen. This diamond-filled atmosphere is not just a fascinating spectacle, but also holds profound implications for our understanding of planetary formation. The presence of such vast quantities of carbon and hydrogen suggests that the planet may have formed differently compared to the rocky planets in our solar system. It may have formed further out from its star, in cooler regions where volatile molecules like methane could exist. This could have provided the carbon and hydrogen necessary for the creation of its diamond atmosphere. Such findings challenge our conventional thinking about where and how planets form, pushing the boundaries of our knowledge and understanding. They remind us that the universe is far more diverse and stranger than we can imagine. A place where the air might shimmer with diamonds, 55 Cancri E takes the crown for the strangest exoplanetary atmosphere. As we continue to explore the cosmos, who knows what other wonders we'll uncover.